So how can you be able to have the sum of terms in an arithmetic progression series, that is AB? So we have two formulas that we use to have the sum of terms in arithmetic progression. And the first formula is the sum of n terms in arithmetic progression is given as should be n over 2 and times the first term plus the last term. Now this formula works if we have the last term, but if we do not have the last term, we cannot use this formula. But that is the formula for the sum of terms in arithmetic progression, where n is the number of terms, the first term as well as the last term. And we also have another formula which says that the sum of n terms in arithmetic progression is given as n over 2 and times 2a and plus n minus 1 times the common difference, and our overall should be in this way. So now this is the formula used if we do not have the last term. Much as we have the number of terms and we have the first term as well as the common difference, we can be able to have the sum of terms actually using that formula. And now, for instance, let's try to go through the following questions, and I should have to appreciate. Now find the sum of the first, let's say 20 terms for arithmetic series, and which is given as a 4, 2, 0, and dot 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 dot. So what is the sum of, let's say, a sum of 20 terms and for this particular actually arithmetic series? And by the way, we're not being given the last term, and these dot dots in this case try to tell us that the numbers are keep on going, so which means we cannot use that formula for the last term, actually the one which is incorporating the last term. We'll have to use the other formula in that way. So now the question that you to have the sum of 20 terms, so which means in that case the number of terms is given as 20, and what is the first term? We'll have it as 4, and what is the common difference? We'll have it as 2 minus 4, and which is equal to negative 2. Then what is the formula for the sum of terms? We'll have sum of n terms being given as n over 2 and times 2a plus n minus 1 times the common difference, which is given as that. Now in this case we'll have it as a sum of 20 terms is equal, the number of terms is given as 20, so have 20 over 2, now should be 20 over 2, and the times 2 times the first term which is given as should be 4, and the plus the number of terms which is given as 20 minus 1 times the common difference which is given as the negative 2, and the overall should be, in this case, let me have to use this actually bracket in this niche, so which means this bracket and this bracket are in pair. You also should have to probably have it here because this negative 2 I've put it in the brackets, so that's how you should have it there. So we'll have it as, we'll have hidden because 20 actually 2 to 20 is given as 10, and we'll have here as 8 plus we'll have should be a 19 times negative 2. So what would be that one? So 19 times negative 2, so 19 times negative 2, we can have it as negative 30, therefore have a 10, have 8 minus, now should be a 38, like that. So now which means we'll have it as a 10 times or have negative 30 in that way. So what is 10 minus actually times negative 30, or have it as negative 300. So this is the sum of the terms. You should have to understand that too. So now what if we have this case? Let's say we have the arithmetic series which is given as, let's say, 4, negative 1, 6, actually negative 6, and the numbers are keep on going this way. So what is the sum of, let's say, 15th term? And for this case should be 15th terms. How should you be able to have the sum of actually a 15th terms? That is sum of 50 terms. How should you be able to have that now? So in this case, which means the number of terms is 50. And since we do not have the last term, so which means we use the same formula. So where the first term is given as 4, the common difference is given as negative 1 minus 4, that which is the same as the negative 5. So what is the formula? We'll have it as the sum of n terms being given as n over 2 times 2a plus n minus 1 should be times the common difference. That will be given as that. So that is, so try to substitute all these parameters into this formula to have the sum of the terms there. Take note of that. Now what if we have been given the nth term formula? Let's say we are told that the nth term formula and for arithmetic progression is given as, let's say, 6n minus 5. So now the question says that find the sum of 60 terms. Should be find the sum of 60 terms for that actually particular arithmetic progression system. So how should you be able to have the sum of the terms in that case? So by the way, in this case, it means the number of terms is given as 60. So now we are given the nth term formula, but first to have the sum of terms, we need the first term as well as the common difference. So how should you be able to have those ones out? So use the nth term formula, and as simple, we'll just have to have the first term, that is the first term, and we'll have the first term, and where actually n will be given as 1. So which means we'll have it as now 6 times 1 minus 5, and which is the same as 6 minus 5, which is the 1. And I'll just need actually a second term. And by the way, we're using the nth term formula that we have. So in this case, it means the n will be given as, so in this case, the n will be given as the 2. So which means we'll have it as 6 times 2 minus 5. And what is that one? So which means 12 minus 5. That will be given as, should be 7. So this is the second term. And as since we have the first term as well as the second term, we can be able to have the common difference in that order. So what will be the common difference? We'll have it as 7 minus 1, which is equal to 6. So now, which means for that particular arithmetic series, the first term is given as a 1, and the second term is given as 7. In that case, it means the common difference is given as 6. So that's how you should have to do it if you are given the nth term formula to have the sum of the terms. That is for arithmetic progression. So the first term has been obtained as 1, and the common difference has been obtained as 6. So that's what you have. So now we can be able to have the actually sum of 60 terms, and like the way actually like the same way we have done it before. So try to have that out at your own time. And what if we have the nth term formula, and let's say it is given as negative n and plus, let's say, 5. So what is the sum of, let's say, should be 80 times if this is the case. So now principal remains the same. In this case, it means the number of terms is given as 80. Don't compromise with this one. So what we need to have the first term, okay, to have the sum of 80 terms is the first term as well as the common difference. So we should have to make use of the nth term formula to have the first term as well as the common difference. We just have to find actually the first term as well as the second term, where we'll be able to have the common difference using that case. So please take note of that, and I try to have that one out and at your own time. You also try this one as well. Let's say we have the nth term formula. Let's say it is given as should be negative 6a minus 2. So what is the actually a sum of should be a 10 terms. So should be sum of 10 terms for that particular arithmetic progression series. So you can be able to have that at your own actually time. And now let's say we have this question. Let's say we have arithmetic progression series. Let's say it is given as should be 5, 10. Let's say we have a 15. And keep on going. Let's say up to 3,000. Let's say that's the case. Now find the sum of actual terms and for this particular arithmetic actually progression series, if this is the case. So now we don't know the number of terms that are from the first term as well as this one as the last term, but I want you to have the sum of these terms. So how should you be able to go over that one? So now in this case, since we have the last term, we use the formula which says that the sum of n terms is given as now n over 2 and times the first term plus the last term. This is the form we can have to use because the last term has been given as 3,000. So we should have to calculate what is the number of terms first. Now we should have to use the nth term formula to have the number of terms. And much as we have the first term given as 5, and we'll have the common difference given as should be 5, it should be 10 minus 5, and that will be given as 5. So this is the first term, this is the common difference. And we are given that the nth term, that is the actual last term, is given as 3,000. Now using the nth term formula, you should have to solve, or should have to find the number of terms that you should have to substitute them into this position. So in this case, we'll have it as nth term formula is equal to a plus n minus 1 times the common difference. So we have the nth term for actually we have the nth term which is given at 3,000. So you have it here. In the first term we have, in the common difference we have, we'll be able to solve for the number of terms. And now upon having those, then we'll substitute in this point. You'll be able to have the sum of those particular number of terms. And much as we have the last term which is the same as that. So try to have that one out in your own time. So that is. And what if you were being given this case? Now let's say we have the first 3 actual terms in arithmetic progression given as x plus 2, and I have 4x minus 5, let's say x, plus let's say 10, assuming that the values are keep on going. So now, what is the value of x? And find the sum of, let's say, 30 terms, and for this particular actually arithmetic series. How should you be able to have that out? So now the principle remains the same. The way we discussed these things before, we should have to find the value of x, and from the principle that much as this is the arithmetic progression, at each and every point, the common difference is the same. So in this case, the common difference here is the same as the common difference here. So that's the principle behind. So if that's the case, then it means we'll have 4x minus 5 minus x plus 2. So in case you missed that lesson, just have to go through that one. I'll have to provide the link in the description actually below. You'll be able to watch that one in case you missed that one. So x plus 10 and the minus 4x minus 5. So now in this case we'll have it as 4x minus 5. We have to distribute this negative. In that case we'll have negative x minus 2, which is equal to x plus 10. And also have to distribute that negative. That will be given as negative 4x and that plus 5. So now we'll have it as a 3x and minus 7, which is equal to, because this and this one, these are actually right terms. Now we'll have negative, should be negative 3x, and that should be plus 15. That is the way to go. So now in this case we'll have 3x plus 3x, and I'll have equal to 15 plus 7, which will give us now 6x, which is equal to, what is 15 plus 7? Now I'll have it as 22. So which means the value of x is given as 22 now over 6, and of which you'll have it as 22. So it should be 22 divided by 6. That will be given as, now as x is equal, should be 3.7, at least 3.67. So it should be that. So that is the value of x in that way. So now what is the first term? We'll have it as x plus 2. Then we'll have to substitute for x, and that we'll have it as actually 3.67 plus 2. So what is that one? So we'll have it as 5.67. That is the first term. And what is the common difference, of which we'll have this one minus this one? So that will be given as, should be 4x minus 5 and the minus x plus 2, and which is the same as, and 4 times should be 4 times 3.67, and the minus, now we have it as 5.67. So what is that one? So now 4 times 3.67, we can have it as a 14.68 minus 5.67, and 5.67. We'll have the common difference being given as 9.01. That is the common difference. So now since we have the first term and the common difference, now we can be able to have the sum of, now we can be able to have the sum of, now should be, we can be able to have the sum of 30 terms in that case, the way we've been discussing these things about. So since we do not have the last term, we'll use the first formula. We'll use the formula which says that the sum of n terms is equal to n over 2 times 2a plus n minus 1 times the common difference. So use this formula. So take note of that. You should have to go through that one. And I believe you have to appreciate that one. That's the nice way to go for. So that is. Now let's say we've been given this case. Now given that, let's say 7th term of an arithmetic progression series is equal to, let's say, a 20. And we are sure that, let's say, the 15th term is, let's say, given as, should be a 30. So now find the sum of, let's say, and that should be 70 terms of that particular arithmetic progression C. So now all we need is to have the first term as well as the common difference. I understand you know how to have the first term as well as the common difference, and for this particular actually part of the question. So try to have that, and now then you'll be able to have the sum of terms in that case. And what if we have this case? Let's say show that the sum of let's say the sum of 16 terms of an arithmetic progression series is equal to, let's say, 200. And let's say the sum of should be 50 terms is let's say should be about 360. Now the question says that find the first term, common difference, as well as the nth term formula for that particular actually progression series. So how should we be able to have that an up to? So now, what is the information corresponding to sum of 60 terms? Actually 16 terms. It means the number of terms is equal to 16. So now, the formula you should have to use is that of, or have it as, sum of terms is equal to n over 2. 2a plus n minus 1 times the common difference in that case. So sum of 60 terms, or have it as 16 terms, or have it as 200 is equal to number of terms 16 over 2, and I'll have 2a plus number of terms, we have it as 16 minus 1 times the common difference. So you'll be able to have the first equation with the two unknowns, that is the first actual terms as well as the common difference, or be unknowns, actually or be unknowns. Then you also do the same with this one. You also have it in the same way, where the first term as well as the common difference will be unknowns. So you'll be able to solve for the first term as well as the common difference using actually simultaneously. Upon having the first term and the common difference, you know how to have the nth term formula from that point. So take note of that. And from there you can also be able to have, let's say, the first 6 terms if you have the first term, actually if you have the nth term. So try to proceed that on at your own time. Now what if we have, let's say, the sum of 20 terms is equal to 50, and let's say the fourth term is said to be, let's say, 15. So what is the first term, what is the common difference, and what is the nth term formula for that particular arithmetic progression series if that's the case? Well, in this case we use the actually a formula for the summation of, actually for the sum of terms, and in this case we use the formula for the nth term formula, and of course we'll have it as 50 terms, that is the sum of 50 terms. We'll have it as, now we'll have 20 over 2, 2a plus n, we'll have it as 20 minus 1 times the common difference, and of which you'll have it as the first equation. You should have to understand. And the next we'll have for this one, what is the formula for the fourth term? We'll have it as a plus 3d, which is equal to 15. You solve for a as well as the d simultaneously, then you'll be able to have the nth term formula, even the first, let's say, 10 terms for that particular arithmetic progression series. So that is. And also let's try to appreciate this question. Now the question says that in an AP, the first term is a negative 5. That is the first term given as the negative 5. And the last term is given as is actually a 1 is our 5, that is 105. That is the last term. So it should be that. Now if the sum of actually these terms is given as 1550, that is the sum of any terms that we don't know. is given as 1550. So now the question says that what is the number of terms in that for that case. So now since we have the last term, it means we use the other formula which says that it is actually the sum of n terms, or have it as n over 2 times the first term plus the last term. We have the first term, the last term in the summation. We'll be able to have the sum, or actually we'll be able to have the number of terms in that order. So take note of that. And also at your own time, try to go through this question. Now the question says that in an AP, the 18th term, that is the 18th term, now is twice the 9th term. So it's twice the 9th term. That is twice the 9th term. So now find the ratio of a sum of 18 terms. So the ratio of sum of 18 terms now to the ratio of sum of 9 terms. The ratio of sum of 9 terms. So try to go through this problem at your own time. You should just have to look for the solution of this problem at your own actually time. So thank you for your time, but don't forget to subscribe my YouTube channel, and for you to keep on updated, and for every stuff that I do upload, and that is best for you. Thank you.